Hello class, so today we will talk about sequenced. So the definitions of sequence is the set of various numbers that continuously increasing or decreasing related to the number before and after in the pattern. Okay, so the way that you can recognize or acknowledge if it is the sequence is just the site A of n or the sequence of B of n. So I just give you the questions. A of n, the sequence A of n equal with 1, 2, 3, 4, 5, 6, 7, more. 1 over 1, 1 over 3, 1 over 5, 1 over 7, more, or C of n equal with 1, 4, 5, 9, 10, 15, and 24. So you can see the sequence of an. The pattern of it is just like n plus 1. When it's just 1, 2, 3, 4, 5. So 2 is just equal with 1 plus 1. 3 equal 2 plus 1. But also 2 equal with 3 minus 1. So you can see the same pattern for it is just 1, minus 1 or plus 1. Okay, so it is n plus 1. For the sequence CBN is gonna be 1 over 1, 1 over 3, 1 over 5, and 1 over 7 and more. So the numerators that you can see right here doesn't change. However, the denominators changing from 1, 3, 5, 7, so which is the odd numbers. Odd number. Okay. For the sequence Cn, it is 1, 4, 5, 9, 10, 15, and 24. You can see right here. So it just 4 minus 1 is 3, 5 minus 4 is 1, 9 minus 5 is 4, 10 minus 9 is 1, 15 minus 10 is 5, and this one is 9. So this is the p-values. So there is 3 types of questions for sequence. Question number 1, they're gonna asking about if the sequence while taking limitations is converge or diverge. So converge means that the result will give you the number like 1, 2, e, pi, so on more. Diverge is the result will give you either positive infinity or negative infinity. And also there's one noticed. If the limit of the sequence n to infinity of the sequence bn plus with the limit of the n to infinity of the sequence cn, the result for limit of the sequence bn is positive infinity and the limit of the sequence cn is negative infinity. This doesn't mean that this one equals 0. By what you can write is just erase this part, and conclude limit of n to infinity of bn minus with limit minus with sequence cn equal with diverge, not equal diverge. The second test is finding the formula for the sequence with given set of number. For example, they're gonna give you like some sequence like 1, 2, 3, 4, 5, 6. Then the set of the sequence is just like n plus 1. That's all. Sequence of dn equal with n plus 1. Okay. The third question they're gonna ask is finding the first 3 terms or more of the given sequenced formula. Type 1, limit for sequenced. Before we are talking more about how to do it, I just want to notice you guys some things. So first, rules about limit is just if limit of n to infinity 1 over n equal with 0, limit of n to infinity of 2 over n squared or 1 over n squared, limit of n to infinity equals 0 too. Limit of n to infinity of 1 over square root n is just 0. Limit of n to infinity of ln n equal with infinity. Limit of n to infinity of e to the n equal with infinity. And then there is 2 rules that you have to apply. So either gonna be L'Hopital rules or squeeze theories. For L'Hopital rules, It is limit of x to infinity of f of x over g of x will equal with, you have to write L prime h right like this, equal with limit of x to infinity of f prime x over g prime x. These things, we notice that this one is different than limit of x to infinity of f x over dx prime. So this one, do not use quotient rule. So there is some things that you have to notice also, that as g of x is not constant, because if g of x is constant, then g prime of x is just 0, which means that you fail on using L'Hopital rules. F of x over g of x cannot be cancelled or factor it to each others. Like the numerators and the denominators cannot be factored. The third condition, that this one I think you have to use the most, is that the functions f of x and g of x should contain either one is the normal functions, like x squared or 3x to the third or so on more. Because when you take a limit of x to infinity of fx over g of x, while fx and g of x is just like cosine of kx over e of x like this, then you, even when you use L'Hopital rules, it's just limit of x to infinity of k to the sine kx over e to the x, and then more. It's just endless. It doesn't have any stops. So if you take L'Hopital rules, it doesn't make any sense at all. So I have some questions for you guys. Find the limit of the sequence, then conclude that it is converge or diverge. Okay, so for example, question A, sequence of an equal with ln n over n to the third. B of n equal with sequence of b of n equal with ln of n plus 1 tam n. C, sequence of c of n equal with n squared minus 1 over n squared plus 1 tam with n squared minus 1. Okay, so for the question A, sequence of an equal with ln of n over n to the third. For these kind of things, first thing that you have to write is limit of n to infinity of an equal with limit of n to infinity of ln of n over n to the third. Please write limit every single steps, because if you don't write on it, then you don't have any point. Okay, keep doing. So now I use local rules. I have limit of n to infinity of 1 over n times 1. This is the chain rule. And derivatives of n to the third is just 1 over 3n squared. So which means it's just like limit of n to infinity of 1 over n times with 3 times with n squared. This one equal with 0. For question B, sequence of en equal ln of n plus 1 times n. Maybe some of you guys gonna confuse about like why do we need to use Liouville rules for this one, because like for normally Liouville rules it's just one function over the other functions, right? However, we can use it too still, since we know that n equal with 1 over n, because it's just like equal with 1 divided by 1 over n, which is n. Okay, so right now we can use this part, this rules apply for this part. So sequence Bn equal with ln of n plus 1 over 1 over n. Okay, so then we take limit of n to infinity of Bn equal with limit of n to infinity of ln of n plus 1 over 1 over n. By L'Hopital rules, it equal with limit of n to infinity of 1 over n plus 1 times with 1. This is the chain rule. And then 1 over n, you can make it as n minus 1. So it's times with 1 over minus 1 times with n minus 2. Which means is limit of n to infinity of n squared minus n squared over n plus 1. You can use L'Hopital rules again. So it equal with limit of n to infinity of minus 2 squared, or minus 2, equal with negative infinity. So we can conclude this one is divergent. Sequence Cn equal with n squared minus 1 over n squared minus 1 of n squared plus 1. Why are you taking limit of n to infinity of Cn equal with limit or limitations of the function inside is n squared minus 1 over n squared minus 1 times with n squared plus 1, which is just, you just cancel in the numerator and you just factor it, so it just equal with limit of n to infinity of 1 over n squared plus 1, which is 0. So this one converge. Okay, so for another question I want to create is just equal with the sequence Dn equal with 10 plus n to the 2n. Okay, for this kind of sequence, you can see it's really hard to use L'Hopital rules, but you can use it somehow, yeah. What do I mean? It's just you have to remember the rules. E of ln a equal with a. So that I just want to make this values as a, so that I have to make it limit of n to infinity of dn equal with limit of n to infinity of e to the ln of 10 plus n to n. There's some one of you gonna ask, like, why do I need to apply this rules? Okay, basically I just want to put off this exponent down here. By that way I can use the rules ln of a to the b equal with b times with ln of a. It is not equal with ln of a times b. Just write this b in front. It's easier for us to see, because like if you write it like this, it just seems like ln of a times b like this. So ln of a times b equal with ln of a plus ln b. Okay, so this one I just move the exponent down, which means limit of n to infinity of e to the 2n times with ln of 10 plus n. Okay, now it is less complicated and it just looked like this sequence. Based on that, we use that rules again, n to infinity of e to the ln of 10 plus n 2 times with 1 over n. This one equal with limit of n to infinity of e to the 2 times with logarithm. Then this one equal 1 over 10 plus n times 1 times with 1 over minus of n minus 2. Okay, then it equal with limit of n to infinity of e to the 2 times with minus n squared over 10 plus n. You can do logarithm rules again, but this one I know that this one ages go to negative 2n, so 4n. So limit of n to infinity of e to the negative 4n, which is infinity. After you've got this step so far, so now we have limit of n to infinity of e to the 2 times with negative 2n logarithm, which is limit of n to infinity of e to the negative 4n, which is positive infinity, even though it's negative right here, but e always bigger than 1. Oh, is always bigger than 0 or equal to 0. So yeah, so it's always gonna be positive infinities. Like I said before, while you doing limit, there's some questions that like you can apply L'Hopital rules, but some other questions you have to use squeeze theories. So how can you do squeeze theories? Actually, squeeze theories is just they asking you for the bounds of some functions. Finding bounds of the given functions and then take limit of the both bounds. and then conclude the between. What I really mean is just, for example, we are doing the sequence dm, then dn equal with -1 n over square root of n. Okay, so right now we can see that is the bounds. So right now I want to, if you can take the L'Hopital rules, which is you cannot, because derivative of this one is hard to use L'Hopital rule. This one is easy to use L'Hopital rules. So that is why you have to use squeeze theories. And actually, so there is the sign for using squeezed theories, which is just like minus of some number, maybe like -1 of n plus 1, or -1 of some n, or -1 of n square. So like n plus 2, not n square, n plus 2 or so on more, or n minus 2 or so on. Or it's gonna give you like the numerator or the denominators of cosine kx, or sine of x squared, so on stuff. Yeah, there's two sides like this. Then you can use squeeze theories. Okay, so for example, the question d of n equal with -1 n over square root of n. You can see if n equaled 1, then -1 n equal with -1. If n equal with 2, then -1 to the n is equal to 1. If n equal with 3, then -1 to the n is equal to -1. You can see the top functions, the numerators, is just bouncing between -1 and 1. So now we set up with -1 smaller or equal with -1 to the n smaller or equal with 1. Okay, can you guys still digest it? And also, if we know that like this numerators is positive, so that when we divide it by square root of n, we still keep the sign. We still keep this is smaller. However, if this one is negative like this, so then this one is like negative square root of n, it's just negative. So then we have to change the sign. What I mean, when you divide by negative of square root of n, we're gonna change the sign. Instead of smaller like this, and we're gonna change the size to like this, because this is 1 square root n like this. Okay, but however, this is the question that we're looking for without the negative sign. By that, we don't need to change the symbols. Okay, so the next step is take the limit of both bounds. What I mean so far is limit of n to infinity of -1 over square root of n, which is 0. Like I said before, limit of n to infinity of 1 over square root of n, which is 0. Okay, So this one, you know, it's go to 0. This one is go to 0. So the between one, is there some numbers that is smaller or equal with 0 and bigger or smaller than or equal with 0? No, it is 0. So we can conclude that limit of n to infinity of minus 1 n over square root of n equal with 0. It's the same with the questions, like some questions like sequenced of c of n equal with cosine kx over square root of n or n square. Let's do it n square so we're not gonna get sick of square root of n square. Okay. So right now we know that cosine of k of x is bounced between minus 1 and 1. When you draw out a function cosine, it's just gonna be like something like this. Okay. Or so on. By that, we have minus 1 cosine of kx smaller than 1. And then we divide free side by n squared. And using squeeze theories, then we have limit of n to infinity of minus n squared equals 0. Limit of n to infinity of 1 over n squared equals 0. This one go to 0, this one go to 0, so this one have to go to 0. Okay. So that is all for how can you conclude what a sequence is. It diverge or converge? Right now we are doing the type 2 questions about sequence, which they're gonna asking you guys for the formula of the sequence. So in the worksheet 14 discussion, it has the questions like the sequence, I name it like dn equal with 4 minus 4 over 5 minus 4 over 25 minus 4 over 125. Okay, and then find the formula. Before we are doing anything further, I just want to telling you guys this question. There's some hint and also some note. If the sequence start with a positive number, then the formula must be of some n of n plus 1, I mean like some constant a. Some constant a of n plus 1 or the constant a of n minus 1. If the sequence start with a negative number, then the formula must be a to the n. Okay, what I mean is like the sequence start with the positive numbers. This sequence start with the positive numbers because this is +4, not -4. If the so we have to use this first rules. If the sequence like we see right here, the sequence of dn start with this number instead, then we can use the second rules. Okay, what I really mean is just the function the sequence dn of 4, -4 to 5, 4 to 25, -4 to 125. As the numerator, it's just from 4 to -4, then 4 to -4. So you can see it just keeps changing the sign. So when it's using the sign, changing the sign like that, it just equal with like -1 to the n. But since like it's have 4 right here, we have to time it to 4. And also the start with the positive numbers, then it's just 4 plus 1, or you can use it 4 minus 1. But you can use it 4 minus 1 if you want to, just like do it 4 minus 1 then. Okay. Some of you guys gonna ask like, why don't we just have -4 of n minus 1 like this? This is so wrong. It's not even like from -1 to the n, it will help you to change the sign, because like 1 to the n is just equal to 1. -1 to the n is just equal with either -1 or 1. But if you have -4 to the n like this, if n equal 2, then -4 to the 2 is 16. 4, n equal to -4, so n equal to 4, so 4 minus 1 is 3. 4 to the 3 is just 4 to the 64, and so one more that we don't need to list it out right now. Okay. So no, for this one, it just the sequence for the numerator is just 4 times with -1 of n minus 1 as the denominator. It equal with 1, 5, 25, 125. So you can see 5 is 5 to the 1, 1 is 5 to the 0, 25 is 5 to the 2, 125 is 5 to the 5 to the 3. The exponent of these things is just increasing. So how can you do these kind of things? Okay, it just equal with 5 to the n, but however, like I said before, when we start with the positive numbers, then it's just 5 of n minus 1. Okay. So when we combine the numerator and the denominator, then we have the sequence of dn equal with 4 times -1 to the n over 5 minus 1 to the n minus 1, or it equal with 4 times with -1 to the 5 of n minus 1. Okay, so some of you gonna asking about limitations n to infinity of dn, which is limit n to infinity of 4 times with -1 over 5 of n minus 1. Using squeeze theories for this one, which is equal with limit of n to infinity of 4 times 0, which is 0. And then the second and the third question is asking what series, so I don't really want to do it right now, we can do it later. Okay, so now we are done with the type 2 question is about the sequence, that asking what is formulas of the sequence. And then the type 3 questions is that they asking you guys about, so they give you a set of sequence which is a of n plus 1 equal with 1/2 of an plus with 2 over an as a of 0 equal 1. And then they asking for the free terms of the sequence. The first term, we have to write a0 first, equal 1. So a1 equal with 1/2 times with a0 plus with 2 over a0, which is 1/2 times with 1 plus 2 to the 1, which is 3 to the 2. A of 2 equal 1/2 times with a of 1 plus with 2 over a of 1 equal with 1/2 times with 3 over 2 plus with 2 over 3 over 2, which is 7 over 12. Then you're doing the same things for a3 is 1/2 times a of 2 plus 2 over a of 2, which you're gonna have is 577 over 408. Okay, and this is the free terms. Don't use this one as the not include in free terms, so don't put it in, like you can write in here, but this is how we calculate the free terms. For the second question, they're gonna ask if the limit exists, calculate for a limit of n to infinity of a of n. So you can see this is n to the a to the n plus 1, this is a to the n. How can you solve for this? And also you cannot solve for a limit of n to infinity of this functions because it doesn't contain any n in here. So by that you know that like a of n plus 1 is just equal with a to the n. It's just like this is the constant, and this is also the constant. Like for example, like it's just the same with like you doing like the integration stuff, and then you have to plus c, it's still the same. By that I name a of n equal with L, and then we have a of n plus 1 equal with 1/2 of a of n plus with 2 over a of n. So this one is just L equal with 1/2 times with L plus with 2 over L. I times both sides by 2, so I have 2L equal with L plus 2 over L. This one I minus both sides by L, so I have L equal with 2 over L. This one is L over 1, so I have cross multiplications, so I have L squared equal with 2, which means L equal with plus or negative of square root of 2. And then we know that this sequence already start with 1, so which means this sequence is positive. By that L equal with square root of 2, which means limit n to infinity of an equal with square root of 2. Okay, so we are just going to the 3 different kind of questions that we are doing for the sequenced.